you know, I'm technically not an hour late. Had 5 minutes to spare, right? Okay. Let's see what this DM is. There's saying things. Okay, so we don't have anything more to Oh wait, that wasn't that was the person who posted the original question, but oh well, it's still someone who's asking a question about math, so um okay. So what do I want to do here? We do have questions in the Discord from Critical. Wait, do we? Yeah. I want to see if Critical comes around first, though. Otherwise, I mean, if it's an hour or two in and we don't see Critical, we'll write an answer for them in text. Yeah. Okay. Because there's a Geometrons in my Discord too, but I'm feeling it's gonna be a little bit too hard for me, so matrix induction. I'm just kind of curious what the question is. Yeah. I agree with what Sophie's saying, so nothing to add there. Oh, okay. This person's asking how we go from e to the t over 3 minus c, and how does the c turn into the k right there? And this person down here explains it, so nothing more to add here. Ah. Oh, you got first, Eldritch. Nice. Oh, you know what? I forgot to send a DM. Let me do that quick. It's late mapping time for you? Yeah, I bet. It's well, A, I started the stream late, but B, also just with the time zones, it's always pretty late for you, right? Good night. All right, well, thanks so much for saying hi, Eldritch, and for the kind words. Hope you get some sleep. See, this one doesn't have... This should be same eigenvalues, right? Or one eigenvalue, I guess. Wait, I did start the YouTube stream, right? I didn't actually check that. Okay, yeah, the YouTube stream is going. See, okay, this person posted a few questions though, so where was I? Okay, well, I don't even know where these threads were. Okay, here. What happened to the other three? Oh, they deleted their other posts. Oh well. Hey, Trojan Mango. Oh, the human benchmark. Okay. Normally when I see a first-time chat and they just immediately drop a link, I'm a little suspicious. But human benchmark, I've heard of. You want to do the number memory one? Yeah, sure. Since the stream is slow. The other person can read 7 numbers at once. Can you do more? 1. Okay. 53. 159. 6177. This is escalating very slowly. 77,646. I feel like it depends on the number. I feel like some are easier to remember than others. 390, 109. Six nine seven 8535. 697 89 8535. 697 8535. 8535. What? Oops. Why did I read that as 85? Let's try again. Call him shenanigan. No, I was saying it. I thought it was 85. Apparently it was 58. You typed 58? I did. I typed 58? Maybe this memory test, maybe I'm really failing it then, because I don't... Oh, I typed 58. Oh, I was saying 85. Oh, I read it backwards then. Okay. So okay. 8040. I'm rusty on using a numpad. 45173. 101942. 4744 166. 4744 166. 4744 166. 4744 166. 335 251 32. 335 251 32. 335 251 32. 335 251 32. Oh, bam. I wasn't sure about that one. All right. Level 9. 223 586 867. 223 586 867. 223 586 867. 223 586 867. Oh my god, okay. 697 641 9785. 697 641 9785. 697 641 9785. 697 641 9785. Oh my god, I got it! Hey Jed, 69, lol, I like it. Hey SG1, 974-934-00372, 974-934-00372, 974-934-00372, 974-934-974-934-0072. No! 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974-934-00372. 974- Ah, 25 watch streak. Nice, Jed. Can I try 2 more times? Sure, Trojan, if it makes you happy. I mean, I don't think this means particularly much. And hey, if some to memorize, I mean, pi, there's a string of digits of pi, like, up front that has a pattern. Mine is a little less than all your friends who are most engineers. I mean, are you an engineer too, or do you, like, work with numbers a lot? Because, like, it feels like just memorizing phone numbers once you get to, like, this length, and I don't feel like I'm good at remembering phone numbers. 3. 68. I wish I could skip through that stage. 165. Trying to be an engineer, trying to be a quant. Okay. I mean, I don't think it's particularly, like... I think this entire thing is stupid if you just get a pen and paper or just, like, a notepad on your computer or something, but... 3018. I don't think this, like, means that you're particularly smart if you can do a lot. 13916. Nine, 6, 7, 8, 50. Didn't practice 3-digit mental math though. Oh yeah. Yeah, I mean that's a really good point. It's probably I tried to do mental math to the greatest extent I can, which means I'm sometimes doing like 3 or 4-digit mental math, and you definitely have to track a lot of numbers in that. 436 9520 436 9520 436 9520 436 9520 320 990 82 320 990. This one's easy. 320 990 82 320 990 82. What? Oh, I typoed a 3 instead of a 0. Dude, I keep just typoing. Hey, Waffle. How's it going? $90.59. $584.46. Oh, how did your geometry test go? 551616. Oh my god, that was almost another typo right there. Like, I feel like there's certain patterns of numbers that are just really easy to remember. If it's a literally random string of numbers, I think it'd be a lot harder. But like, if there's like 9548513, 9548513, 9548513, 9548513. I just like 90% of quants to be above average on this. I mean, I don't know. You got a perfect on it? Oh, nice. That's awesome. 215-14803, 215-14803, 215-14803, 215-14803. 703-8985, 703-8985-76, 703-8985-76, 703-85-89-76? No! I messed up the 85-89. All right. So there you go. It's half and half between 7 to 9 and above 9. All right. I mean, I'm not going to do like these challenge things for much longer, but I'll try out the arithmetic one. Hey, Fembucks. So addition is, the range is 2 to 100 for addition? Sure. Okay, sure. Just gonna leave all these as default. Oh, fuck. 154? 68? 157? That should be easier than it was. 130? No? Clearly not. 120. 5. 116. 79. 63. I'm just gonna keep saying that's 99. 400. 23. This 132, dude. Clearly. 7. 8? No, wait. What's the trick with this? Okay, fine. 4, 3. That's the trick. I was trying. 150 minus 5, 145. 12 times 90? I'm like, who knows what that is? 12 times 9 is 98. 980. Add 90, 1070? 1080? Ah, I don't know this one. Oh my god, 12 times 90. 12 times 9. That is 98. Add a 0 is 980. You add 90 again. 1070? Did I already say 1070? Dude, I'm just bad. I can do 1200 minus 8 times 12. I'm supposed to add 12, aren't I? No, I don't know, dude. I'm too stupid for this one. $10.92. All right, fine. I don't put like that much stock in those things. Types things are so fun. Yeah, it can be fun, but like I don't necessarily think it means that you're like. It depends how you want to define smart, I guess, but it doesn't necessarily mean you're smart to me. It's fun and it's a cool skill, but when you speed it for a competition, it didn't help. Ah, dang. Okay. 3 in a row. Ooh, nice. Thank you for the watch streak. Oh, fair enough, Trojan. One friend you think is failing math got like high 30s on one. It was scary. Yeah, I mean, it depends how you want to define math. But I think doing mental math like that is kind of a separate skill from doing like studying a high level math, or not even high level math, but like being able to do 12 times 91 quickly in your head doesn't really help you even for like geometry that much or something like that. Like there's one kid, a friend in high school. He did not do well in his classes. I think more because he wasn't trying. But for Pi Day, the school had a competition where whoever memorized the most digits of pi would win an actual pi. And in a single day, he memorized like over 100 digits of pi and won the competition. Like he only studied the day before. Hey, Zach. Oh, Zach, you tried it too? I wouldn't feel bad about not getting like a good score on that thing. Like, or you saw me just fail at 12 times 91 also, so like... Loan amortization? I don't know about that. doesn't this not converge? Wait, what's this last? Wait, what? Why is the last one minus? So is this the pattern and then you're just randomly minusing the 2 over root n? A 54 on the arithmetic one? That's kind of insane. Yeah, I don't know how to do this one. I'm already kind of done with Reddit, I'm gonna be honest. Which kind of leaves me with two options here. We can do some algebra, or I'm thinking that I can start looking at the book for the reading group that I want to do for physics, and maybe come up with a plan for how much we should read and how soon. Or at least, like, you know, come up with a suggestion anyway. Oh, thanks for doing that, Femvox. So, I don't know, yeah, let's at least, like, start taking a look through the book here, because we have two options. Stuki and I are both leaning towards this one on the screen by Purcell, and I don't think anyone else preferred a particular book, so it can still be, like, Oh, Pi! How's it going? Yeah, I've been itching to try to learn E&M again. I took a class on it in college, calculus space. It was super hard. I had a really hard time with it, but I'm wondering if it'd be more fun with multivariable calculus. So there's gonna be like a group of us who are gonna hopefully meet every week or two and kind of like go through the chapters here. But I hope you're doing good, Pi. I haven't seen you stream in a minute, but hope that things are good on your end. Just have to run home, you at work, but catch you in a few. All right. But yeah, I was thinking of, at least for now, going through this a bit and looking at, I think chapter 1 is pretty huge, so I don't know if we want to divide it up or just give like 2 weeks to read the entire thing or something, but been busy, but been well. That's awesome. Yeah, I'm doing good too. Let me catch up on what Trojan Mango is saying. Probably been doing it like 10 times a week for the past 3 months. Your score is not improved. I was practicing 2 hours a day, like was for mental maths. Huh. Yeah, there's definitely, it steps in difficulty doing mental math quick. Because even though it's only like 1 extra digit each, as you do the math along the way, you have so much more to keep track of. So yeah, I think I kind of want to skim through chapter 1 and just see how much is really going on with it. And if we can, like, it'd be nice to like maybe say like, you know, read up to this way in chapter 1 and we'll try these exercises together. The book you said it was Griffiths? Yeah, that was the other option that we are gonna actually even have a PDF of it still. Have to, where is it? So like I kind of like left it up to everyone. What did I just do? What we want to do, because there's a physics streamer, physics impression, who asked for like recommendations, and these were the two that he said. Brings you back. Yeah. And so this one, like I guess this was kind of like the standard one that it's pretty frequently used, but this one is kind of interesting because it apparently introduces relativity super early on as the explanation for magnetism, and that is kind of intriguing to me because I have no idea how relativity actually works. I never actually like studied it. It's like, ooh, it could be cool to like learn about. Um, but yeah, I was interested specifically in doing like a multivariable calculus because the class I took in college didn't involve any, and I guess the multivariable calculus class that I took, I really enjoyed. So this one seems like it's going to have at least some in it, even though it doesn't seem like it's going to be super frequently physics in general. So I imagine chapter 1 is going to be a lot of like and part of this book that makes me nervous though is that I don't think it goes over any of the math prerequisites. It just gets right into it, whereas the Griffiths book has a pretty meaty chapter on all the vector stuff that you might need for the Griffiths book. But I'm sure it'll be fine. I mean, this is kind of just like a higher level conceptual stuff. I guess it's not getting too, it's not gonna get that heavy in the math, so it might not be too unreasonable to just skip through all of chapter 1. I'm not sure. So you should already know. Yeah. So it's like I learned it. I'm just not like the strongest on it, but I'm sure I'll be able to like relearn it fast enough. Hadrons? Oh wait, okay, they're already getting into quarks here. Oh my god. Okay. And the first actual math that we have, or like we have an actual equation here in section 1.4. How many sections do we have in total? Okay, yeah, now it's getting heavier. Gauss's law. Setting up your conservation stuff. Okay. Yeah, because a couple months ago I read what's it called? Stephen Hawking's book, A Brief History of Time or something, and it kind of like gives a, like it's like a layman's explanation, or what the term is for like quantum mechanics. But that's like the total experience that I have with this. All right, so we go up to page 39. 16 sections, geez. I'm getting the feeling that all it's going to build on itself, and like trying to do half and half might not be that good. I don't know though. So yeah, Coulomb's law. It's the unit vector in the direction from the charge 1 to charge 2. F2 is the force acting on charge 2. Okay. I can buy that. Except I think I know you studied physics, or that you also like teach it. Like I don't know, like did you like a bachelor's, like a master's, or if you don't mind saying it, if you don't want to say, of course, it's no worries, but just out of like curiosity. Did some math classes but didn't finish it. That's fair. I've done that with software engineering, actually. Started one, but I didn't finish it. But yeah, I studied applied math, and there's some parts of like the more pure part, of pure math that are cool enough, but there's already quite a few other like math streamers out there who do pure math stuff. So I think I do the complete opposite here. So you teach AP physics calculus based. Oh, nice. Okay. I didn't know that AP physics went into calculus based. For me, I assumed it was algebra based, but I guess I don't know why. Is there actually an AP algebra based physics? I don't know. It's the one you'll agree to teach. That's fair. The algebra based one makes no sense. Yeah. Because I've thought about like, you know, trying to get into, oh, maybe I can teach like high school or something like that. But I just think about like trying to teach kids who don't want to be there sounds kind of painful. But at least if you're teaching like AP classes, they're going to be a bit more willing to be there, I think. Core concepts are not applicable for students that would go into engineering and physics. Okay. If they choose to take your classes, yeah, exactly. What's happening here? This reminds me of like multivariable limits where like you have to consider every single path, but I think this is something completely separate. Oh, for work. Okay. Path integration. I probably shouldn't try to jump halfway through a chapter and think that I'm going to understand it, but if they build on each other, yeah. Energies in a crystal lattice? Ooh. It's fun stuff too. It looks like it. The more I look at this, the more I'm getting the feeling that we should maybe how they get watches to work. Really? I hope they talk about that in some spot here. Actually, I probably want to be in there. I did see an applications section somewhere. Crystal vibration via voltage across it. Wow. You know, the more I think about it, I haven't seen too many example problems here. Like, there's an example problem right there. They're introducing a lot of concepts and equations here, but it'll be interesting to go straight from concepts to practice problems, I guess. Actually, applying sounds so cool and terrifying. I agree, Walrus. I've got to do this specifically because it's going to be hard, I think. Like, I don't expect to have an easy time with any of this, but I don't know. Is it worth trying to learn something that's easy, I guess? So yeah, see, this is the book you use in college. Oh, really? So yeah, Finvox, if you didn't catch the first part, I'm trying to like figure out if it'd be a good idea, I'll come with a suggestion to start off the reading group with. If we want to say maybe like take 2 weeks to go through all of chapter 1 and then we'll try the practice problems, or you know, we can discuss chapter 1 and then go through practice problems, Or if we want to try and like split it up like half and half. But since it seems to like build on itself so much, I'm kind of thinking take a longer time to go through all of chapter 1 and then come back and discuss it. And chapter 1 is super big though. Well, what do the the problems look like? I might help inform this. If they're clearly related to like just one section, then maybe we can split it up still. And after this, I'll probably go and do critical thinking's questions in my Discord. I just wanted to give critical some time to get on to the stream, but it doesn't seem like that's going to happen. Then we'll go through and just answer their questions in text. But this is a nice thing to like fill in time, I think. Turn thing is start with a conservative pace. You can always pick it up later. Yeah. So I think 2 weeks to get through chapter 1 is reasonable. Yeah, I feel like these practice problems are going to be a mix of a lot of stuff. Oh, we're saying to use Mathematica for this one? Huh. I'd have some code writing or something to do. I don't know Mathematica, but... It feels like I don't know if there's a huge point trying to split up chapter 1 because I feel like maybe these problems shouldn't be attempted until we have all of it under our belts. Oh god, and we have exercises too. These seem a lot more applied. Your semester finished on Tuesday. Oh, cool. Yeah, and we can definitely like, I guess we can even like potentially set like 2 weeks as like a soft goal and then like check in and see if we want more time or not. That might be a better way to like phrase things. Okay, well... Let me bring up Discord here. But I mean, this is normally this is something to do off stream, but you know, as long as we're trying to fill in some time, let's write this message out. It seems very... Actually, oh wait, no, I'm making an assumption already that we're going to use per cell. Unless anyone has any objections, I think we'll go with the Purcell book. Or Purcell and Moran, sure. recently. Huge chunk. And we got these two series questions. There's a geometry question in here too, but I'm kind of scared of that question, so I know we're gonna do it. How much exposure do you have to physics? The electrostatic chapter is going to bring gravity into the problems a bit. Electrostatic? Which one was he? Was the electrostatic chapter the one I was like looking at? Yeah, okay. I've done calculus-based physics 1 and 2, which were mechanics and electricity and magnetism, just using single variable calculus, and I got good grades in those. Not necessarily means that much because what's it called? I just kind of do whatever it takes to get an A, and also I understand the concepts when I'm a student taking a class. Okay, if I'm able to skip over those, that'd be nice. I get the feeling that these first few sections aren't actually that bad. It's just kind of like introducing you to the idea of like what is electricity and all that. I'm almost scared of like the last half of the sections though, where they get into stuff like this. I guess that just looks like a spherical integral, which might not be that bad. Summation of forces, equilibrium. It's going to be in those problems. Okay. That's the stuff, like, I'm kind of worried about not remembering that stuff that well, but I feel like I'll be able to, it'll come back to me. Might be a rough start, though. Go down to those problems? Yeah, sure. Look at the first one. Where are we? Wait, are these the problems? Am I crazy? Okay, yeah, so these are like, oh, okay, yeah, I assume you mean this one with gravity versus electricity. How about two? Okay. In the domain, I don't, let me actually like read these, because I only like barely skimmed it. Proton or neutron. Aren't neutrons a tiny bit heavier than protons because they have the electron? Maybe I shouldn't overthink this. Let me just take the book at its word. Compare the gravitational attraction of two protons with their electrostatic repulsion. Oh, right. Isn't, I do remember, like, this concept where gravity is considered very weak because, the equation for gravity is proportional to the inverse square of radius. And I think the force for charge is just the inverse of radius rather than inverse square. Both are inverse square? Is it just the constants, I guess? That makes it weaker? I'll have to look at that. Oh, hey, Mario, a differential equation. I think, yeah, we should be able to do that. I mean, I'm gonna have to think about it a little bit, but can we do reduction of order on that since there's no y term? The unit of charge compared to mass. Okay, interesting. Constant use in electrostatic force is 9 times 10 to the 9. Oh, versus 10 to the negative 11. And the, okay, yeah, the basic, the mass is 10 to the negative 27, and the charge just, I think we just call it 1 for a proton, right? So yeah, let's look at Mario's differential equation, I guess, to compare it to the mass of planets. Oh, true. And first off, Mario, before you forget, if you haven't seen other math streamers out there, like if I'm not around and you have a math question, there's a whole list of other math streamers there who I can recommend highly. You're talking about y double prime plus y prime equals 2x. And my first thought is, all right, I'm thinking about reduction of order. I don't know if that actually works here, though. This isn't the explanation that I was looking for, to be honest. I thought there's a different trick, isn't there? It might not work if it's non-homogeneous, I guess. We can always do just the regular second order stuff. I feel like there's a trick for this one, and I'm just maybe a little bit too rusty with this, but I guess, Mario, have you done like undetermined coefficients or variation of parameters? I think it'd be as simple because we're just equal to 2x. Variation of constants? Okay. We can do that. If I remember... Yeah, this is it. So what we get are homogeneous solutions. And when you get the particular, basically just using this formula here. Huh. And what's our Wronskian? Yay, intelligent. It's been a minute. Nerds unite. How's it going? Oh, the Wronskian is determinant of 2 by 2 matrix with y1, y1 prime, y2, y2 prime. Okay. So it's been a minute since I've done variation of parameters here, Mario. So if I make a mistake, forgive me, I guess. I did get new marker ink, by the way, so I'm not just restricted to like red and green again. So we have y double prime plus y prime equals 2x. So I guess we start by getting our homogeneous solutions. I solve the equation y double prime plus y prime equals 0. Oh, thanks for the follow, Mario. It doesn't. I hope you've been good. Okay, I'm thinking there's some kind of trick because of like this situation here. You probably just like on that you could do like a substitution or something. But if it's non-homogeneous, I don't know how that works exactly. So. But if we say that the characteristic equation is r squared plus r equals 0, we will get r times r plus 1 equals 0, r equals 0, comma, negative 1. So our homogeneous solutions are c1, well, e to the 0 is just 1, so we get just c1 plus c2 e to the negative t, right? It's kind of interesting. Then our particular solution, I feel like there should be an easy, like, I don't remember it being this weird of a formula when I learned this in my differential equations class, but we can use it. I'll bring it up on screen in case it helps to actually like see it too. I bet there's some kind of trick to solve this problem simply, but if you have to use variation of parameters anyway, that's going to help me not have to spot the like whatever trick might be here. Okay, so we want to do... I should actually have written this a bit differently. We get that y1, our first homogeneous solution is 1, and that y2 is e to the negative t. So our homogeneous solution is a linear combination of those two things. We don't start counting from 2, though. And now to get the particular solution, I'm just going to plug it into the formula. So negative y1, negative integral. Oh, you know, we need our Wronskian, though. Guess a polynomial of degree 2. That's probably the trick there, Fembox, yeah. But since Mario said variation of parameters, I assume we gotta do it this way. Or you said variation of constants. That actually, could that mean undetermined coefficients? I just realized I might be misinterpreting you, Mario. Or maybe there's a translation issue as well. So I saw the word variation, I was like, oh, variation of parameters. But I just realized variation of constants, you could interpret that as undetermined coefficients. Hey, critical. Sure. I'm gonna get through Mario's first, and then there's no one else who's waiting. Okay, so... Did the thing I was about to do, Mario, look familiar? I'd also... it'd be bad of me to misinterpret you here. You're right, it'd be bad of me to misinterpret anyone at any time, but... Does the method involve guessing what the particular solution should be based off what your function is? Like... I had to go one power above. Yeah, I was just thinking that, Fembox, that at least in here, they do the same power. Does the actual solution involve a second power? It does, really? Okay, let's cheat and look at what the answer should be in Wolfram. If you guess a linear function, it won't work. You are right. Huh. Why? We have an nth degree polynomial and we guess an nth degree polynomial. That's super weird. Certain polygons that have like a similar thing. There's no y term on the left-hand side of the DE. That could be it. I'm not sure why. That will make sense, I guess. Y double prime plus y prime. Let z equals y prime first. Oh! That would do it, Fembox, yeah. So I was just curious about what a substitution would do for us here. I just wasn't sure how it would affect x, but maybe it just doesn't affect x and that's okay. So that's the thing that I was trying to do like the first time when I saw this problem, like make it just 1 degree less with a substitution. One second, I'm gonna put my mug away. I guess let's do that. So yeah, Mario, I'm sorry that I'm not giving a very clear explanation here. I guess what I'm still unclear on from you is the actual method that we're supposed to use, because the two methods that I'm familiar with for solving a differential equation like this have very similar names. And a lot of times there's like, or especially if like things are getting translated from another language, it makes it even harder to actually know. So I guess the work that I did here is still valid for the homogeneous solution. But if we want to come down here and find the particular solution, or even come to the right here. Particular. I think I like what you're saying, Benbox. It feels a little... I want to it feels a little weird, but on the other hand, I guess it's what we do. We can let z equal y prime. And that implies y double prime is z prime plus z equals 2x. And you can solve this in many different ways, but if it's just equal to a polynomial, then we can be reasonably sure that the answer is going to be a polynomial. And so if you derive it and get to a first order polynomial, that means we have to guess a second order polynomial. Could we have used that logic over there? If you derive it twice, I mean, I guess I would have guessed a cube by that logic over there, which would be okay. The cube would just go away. But well, I guess let's keep going down this train of thought. It's just weird. I don't know. This whole thing feels weird. Guess that z equals, let's say, ax squared plus... I'm mixing x and t, aren't I? Oh, they use x in the initial... Ugh. Dude, you can tell I'm rusty on this stuff. Plus c. Oh! I didn't have my headphones on, so I didn't even hear that. But Frog Dino, thank you so much for the prime. I really appreciate that. Constant variations is an exercise that was assigned to you without context. Oh, really? I guess constant variations, the name of it is still... The more I think about it, the more I feel like you're supposed to do undetermined coefficients. But undetermined coefficients and variation of parameters, I feel like they mean basically the same thing. Mathematicians are just supposed to know the difference. I don't like it. Would the technique that we're using here make sense to you, Mario? Like, do you think it's in line with... I guess you see you don't have context, but this is like... It was hard for me to spot it on my own, but I think this is the simplest way to go about this. So if we're guessing that z equals this, we know z prime equals that, and we can plug it in up there. C equals 2x. And then... Doesn't a equal 0 here? I'm confused. Oh yeah, a is supposed to equal 0. Yeah, we would only guess a linear. Sorry. That was the entire point of this. I guess so. So it would have been fine to guess a quadratic as well. Your square term will just go away. So you only need to guess a linear term, so it's more efficient. And I see now what you're saying even more, Fembox, why the not having the plus y there is what changes things. Okay, right, because if you're guaranteed to derive it at least once, and you end up with a linear function, you must have had started with a quadratic function. That's a really interesting, like, distinction, though. Like, I feel like when I was taught this, we never made that exception. So I probably would have done this problem wrong on a test. But yeah, if we plug this in, we get a plus ax plus b equals 2x. We're going to equate coefficients. So we're going to get ax plus a plus b equals 2x. So we know that a must equal 2, and that a plus b must equal 0. So b equals negative 2. So that means we solve for z. That's 2x plus, or 2x minus 2. And then z is equal to y prime, so if we want y, we need to integrate z. Which is, oops, that 2 goes away. Do we need the constant of integration here? Either way, it wouldn't matter because we have that c1 there conveniently. I feel like you do in general need a constant. That's just kind of a guess. I need to look at an example problem for that constant. That sometimes gets me tripped up, but our final answer for y would be that plus that, basically. And we're gonna have a constant plus another constant, which is why it doesn't matter in this problem anyway. So you say, I'm just gonna delete C2 entirely. Yeah, Penbox, that's kind of, I guess the rationale is it's not really a second degree differential equation. Could we have just solved this entire thing off the bat as a first order linear? Like if we use an integrating factor, we should get to the same answer. Your chicken scratch is distracting. Got me stumped. Yeah, Mario, no worries. I'm sorry that I can't give you a firm answer or like a better, like, I'm sorry I can't say this is definitely the way that you're supposed to do it because I'm just not sure, but this is a way to do it. No need to stick around for it if you don't want, but I am curious, just for fun, to try out an integrating factor. There we go. I should know this formula just from being able to derive it, but I actually don't know this formula offhand. I have to look it up each time. So the integrating factor is e to the integral of p of t, and p is what's in front of the y. Then you integrate the integrating factor times g divided by the integrating factor. Okay, so I want to try it this way too, just for fun. I want to see if it's going to get the same answer. I guess it should. I don't know. So if off the bat we do that same sub with z equals y prime. This is the thing I was trying to do off the start, but I was nervous about like what the 2x change if we do the sub, but I guess we can just say it doesn't. So if we solve this with an integrating factor, we'd say that z equals 1 over, that's just e to the x. Or yeah, that's just 1, so we do e to the integral of 1, and the integral of 1 is x. So 1 over e to the x times the integral of e to the x times 2x dx plus, because we do parentheses, plus c. So 1 over e to the x, how does that thing integrate? I got to do integration by parts, right? We want to derive 2x. We want to integrate e to the x. du equals 2 dx, v equals e to the x, multiply, multiply. So 2x e to the x minus integral 2 e to the x dx plus c. It's 1 over e to the x. This could be messy the more that I look at it. Not because of this part, but because of the next part after this. Oh, maybe not. We're probably okay. So oh, funny that. Yeah, our e's do go away. Except for 1. Okay. So if we multiply this 1 over e to the x in, we get 2x minus 2 plus c over e to the x is z. But we need to integrate this to get y prime. Or to get y, sorry. So 2x minus 2 plus c e to the minus x dx. So that's x squared minus 2x minus c e to the minus x, but you can call that plus because it's a constant of integration in front, plus another constant d, which matches. That's kind of cool. That we get the same answer either method. Wait, oh my god, Fenbox. Wait, did I correct myself and then not actually correct myself? I'm so used to using t with differential equations that I get thrown off when x's are involved instead. I erased the t's and wrote a t right back there, I guess. Okay. That's a neat find, Fenbox. Thanks for the help on that. Okay. You have 2 more to solve? Okay. That's fine. I'm happy to keep on trying to work through these. But there's another person in chat, Critical Thinking, who's asking questions as well. So unless one of you are under a particular time constraint, I'll switch off. Like answer one question from one person, and then switch to the other person. So Critical, if you are here, let me actually see if Critical's here. Maybe not. Mario, if you want to post like the next one, unless critical shows up in a minute, we'll just do your next one too. If you want help, or if you want to try it on your own, it's up to you. In the meantime, I can erase the whiteboard. But I'd wait to hear from one of you. Oh shoot, I never sorry about the glare that's on the whiteboard. I forgot to close my blinds. There we go. It's still kind of there, isn't it? It's annoying. Oh, you're playing Portal 2? No worries, Critical. I'm gonna switch off between you and Mario since it sounds like you both have multiple questions, so I'll alternate. Out of the questions you posted in the Discord, which one do you want to see first? Okay, also, new cloth. Okay. Yeah, okay. Hey, Obi. Do Mario's first? Okay. You're very neat. Thank you, Obi. Okay, so this is like an evolution of the other problem. And yeah, Obi cut straight to the chase there for the characteristic polynomial. Oh, yo, thanks so much, Mario. I really appreciate that sub. Holy crap. But okay, and yeah, critical. Once I'm done with Mario's problems, then since you say that you can wait, I'll come to 33 for yours. Okay. Sounds good. So this one should be more normal because this time we do have a y term. Emphasis on should. Let's do blue. Y double prime. I already forgot the rest of the numbers. Minus 2y prime minus 3 equals 3x plus 7. Oh, 3y. Okay. So, as Obi said, we're gonna start by solving the homogeneous equation. Is there an E right there? I feel like there is. Doesn't matter though. So let's solve y double prime minus 2y prime minus 3y equals 0. And we do that by finding the characteristic polynomial, which is r squared minus 2r minus 3 equals 0. And then this is just a quadratic that we have to factor, so we get r minus 3 times r plus 1 equals 0. So r equals -1 and 3. That would mean our homogeneous solution is c1e to the negative x, not t, c2e to the 3x. There is an e there. Okay, thank you, Obi. And then let's do the particular. So I'm going to do it the same way as last time, doing the guess way. And because this time we do have a y term, there shouldn't be anything that weird here. So So if you're just equal to a polynomial, then you can guess a polynomial of the same degree. So we're going to guess that y sub p is ax plus b. So degree 1 polynomial, but the coefficients we're leaving up to be determined, which is why it's called undetermined coefficients. So 20 mark. Oh, welcome in, Lucky. 20 mark question, which was integral cube root of tan x from 0 to pi over 4. Yeah, Lucky. I haven't seen that on a test, but I've seen a black pen, red pen video about that, and that one's a crazy one. It's easier to find the substitution if you break it out into different steps, but it's still a super difficult integral. But yeah, welcome in. And Obi's asking a question about understanding why the harmonic or the homogeneous solution exists. And so what I'm showing you right now is kind of like the blind process of plugging things into formulas, which works to get you a good grade in a differential equations class a lot of the time, if it's just like a first-time differential equations class. But there's a much more theoretical version of this that I'm skipping entirely, but I'm showing like the procedure of how to actually solve these. And actually, OB is going to be doing a differential equations class, it's my understanding, over the summer at some point here. So when I say OB, I mean n-simplex pachinko. I should say that. But yeah, so that's our homogeneous solution. For the particular solution, we're going to guess this for y, but we want to plug it in up here, but we need to find y prime and y double prime, so we can use calculus to figure that out. So we derive this to get just a. And is this always going to happen where we get 0 if we guess an equal degree? It's kind of interesting. But I'm just going to go with it. Actually, no, let me plug into Wolfram Alpha quick, just to make sure I'm not on the wrong step here with this sub. Or this guess, not sub. Because I don't want to do a whole bunch of incorrect work and have to correct myself after. No, we just get a linear. Okay. Oh yeah, it's a nice way of talking about it, OB. Because towards the end of my degree in the last year, we were viewing this as like a spring mass system with an acting force on it, like you were saying. In the differential equations class, you normally just learn about that in a vacuum. Like some of this can be modeled to use like if you have like if I remember right at least, if you have like a spring in a mass, that kind of like part here can be used to model like how far back you pull or whatever. Like it can often be like an initial force that you exert, and then it goes into its own like equilibrium steady state solution in the long term. The 3x plus 7 wouldn't have that effect. That'd be a different thing, but it's called like dampened forces or something like that. But there's a whole bunch of like physics interpretations with these, but in differential equations class, you don't really worry about these for your like the first one you take anyway. But I should stop rambling. Let me actually solve the equation. So we figure out what we have our guess for the particular solution. We derived it twice, so let's plug these in. So it'll be 0 for y double p prime minus 2a minus 3ax plus b equals 3x plus 7. Okay. Now we want to group like terms, so the x's go with the x's, constants go with the constants. So we get minus 3ax minus 2a minus 3b equals 3x plus 7. So we can match things up based on the x's, which must equal each other, and the constants, which must equal each other. So we get negative 3a equals 3, and minus 2a minus 3b equals 7. Now we have two equations, two unknowns. Let's solve it. A over here is just one step, negative 1. Let's plug it in over here. So we get positive 2 minus 3b equals 7. We're going to get a fraction. Minus 3b equals 5. B equals minus 5/3. Make sure I did that right. Yeah, we do get a fraction. That's just the way it is. Okay. So we found our a and b, so let's plug it back into our guess for y sub p, which is the particular solution. So a is negative 1, so minus x, b is minus 5/3. There we go. Now the general solution for y is homogeneous plus particular. So c1e to the minus x plus c2e to the 3x minus x minus 5/3, I'd say is the answer there. That should match Wolfram alpha. And it does, yeah. Yeah, so the exact thing that I said with the spring example wasn't what's happening in the equation that we had, but that's the thing that comes to mind for me at least. Harsh shocks are an easy application. Oh, interesting. Derive and differentiate are not synonyms. That's true, Fembox. I tend to use them interchangeably because I just don't care, but they do not mean the same thing. Or, it's improper to, or you technically shouldn't use it too loosely. But yeah, Mario, let me know if you have any questions about the solution that I wrote on the board. And if not, feel free to post the next question. No worries. Differential equations are fun. I haven't been using them enough to be that sharp on them recently, but I do enjoy these a lot. That's the last one. Ooh. This one is separable. Okay. This one we could do an entirely different way. It's actually, funny enough, you could do each of these three differential equations in completely separate methods. And I would actually recommend that because different techniques are easier for different functions or for different equations. Y double prime equals 12x squared plus 4. So this one is a really nice type of differential equation because that's a very direct way to solve it. And that's called separation. Although even then, like, we don't have any y's involved, but the idea is that oh, sorry. I'm gonna rewrite y double prime as d squared y over dx squared. It's 12x squared. I mean, this is making it more complicated than it has to be. Okay, let me make it simpler because this is kind of uncalled for with an equation like this even. We can just integrate both sides twice, is the moral of the story. So we know that y prime is going to be the integral of y double prime. And we know what y double prime is exactly, so let's just integrate y double prime, and then we'll integrate y prime. 12x squared plus 4 dx. There's so sometimes you can have like a y involved somewhere over here, and you have to do a bit of extra work. But for a problem like this, I'll just keep it simple and do it this way. So if we integrate this, we do the power rule, and we get 4x cubed, right? Plus 4x plus constant integration c. And then we know y is the integral of y prime. So let's plug what we just got in down here. 4x plus c dx. And then we integrate this to get, oh look, they even had it work out nicely with the coefficient, so it would go away entirely for to the fourth term. Did I miss a power? No, it's just, okay, never mind, there's still a gap there, I guess. That integrates to 2x squared. C is just a constant, so it integrates to cx. And then we get a second constant of integration here, d. So I'd say that our, this right here is the solution. Let me check that though. Just because I want to try to make some kind of stupid mistake here. Wouldn't be the first time. C1x, C2, x to the fourth, 2x squared. Okay, good. It matches. Mine looks just a tiny bit different, but it's equivalent. So yeah, for one like that, Mario, just integrate each side twice is the moral of the story there. Do we have any questions there? Use the wrong hotkey. I'll wait to hear back from you. I'm going to look for Critical's question. No worries, Mario. Glad I could help. If you're into anything else, let me know, or feel free to ask any people who I linked before. Because I'm pretty sure all of them can do equations like this. Maybe Danny Highway. I think Danny Highway can. Critical is lost in a portal. Let me add Critical here. You here? Okay, cool. So I pulled up 33. series is convergent or divergent. If it's convergent, find its sum. Didn't we do this one with Penn Center? This looks familiar. Do you think it's divergent? Okay. I agree that it diverges. You want me to elaborate? Okay. Were you able to find the formula for this pattern in terms of n? Like, could you translate this into normal summation notation? Like you know, something that looks like that, but for the string of numbers up here, 1 over 3n, perfect. And what was your idea after that? Or like, why do you feel like it's diverging? Because it's increasing. Well, each term is less than the other, or is less than the next one. The graph is going up? I think you graphed it wrong. Hey, Zane Alcazar over on YouTube. What's the question? So the terms of the sequence are decreasing. I'm trying to phrase this right. It's vectors. What about vectors? If it's easier to post a picture, I have a Discord where you can do that. Or if you're able to type it out in chat there, then that's fine too. So it's true if you graph the sum definitely increases. But that's kind of true of every series that's not alternating. Because you're just adding infinitely many things. You can't do infinite sums here. This is kind of a poor demonstration in Desmos, because Desmos isn't really built for sequences, I don't think, but it's like the sum, it is increasing, but it's kind of really? Did I do this wrong? This can't be right. It looks like it's converging, but I don't think it shouldn't converge. Yes, Zane, if you're able to just type it out and you'd rather do that, then you're welcome to type it out as well. But if somebody's need to post a screenshot, so if you want to do that, that's what my Discord is for. Let's see your logic. Yeah, so I was trying to understand what your logic was. Oh, that's the key, Fembox. Thank you. What I would do here, critical, is that this 3 is just a coefficient, like it's a constant. It's valid to pull it outside of the summation entirely. So like this, I haven't changed a single thing about it, but yeah, like this piece here diverges, so the 1/3 doesn't even matter because the 1 over n just already diverges. That's logic that I would use for this problem. How do you solve the problem from here? I think you've solved, I mean, I would write this and then say 1 over n, or, you know, the harmonic series diverges, or like as soon as you like write it in this form and you recognize that it's a harmonic series, you're done. you can just say that it diverges. There's nothing else to solve, I guess. Right, you don't have to do anything. You can only really find the actual sum of the series if it's geometric. I don't remember another series that has a clean infinite sum aside from geometric. There might be some special cases that do. And hello to Last Chance over on YouTube. How does 1 over n diverge? I'm curious. So I should make a distinction here. So I'm not sure of your background. Last Chance. Oh, telescoping as well. That's a good call, Fenbox. Also save for the n versus x thing. So 1 over n as a sequence converges to 0. Let me make it simpler. So if you just take, this is a function, but because Desmos doesn't do sequences, I don't think. But this sequence, it does go to 0 if you look at the individual terms. But it turns out that if you were to take the sum of the terms, it's going to diverge. It's going to do it very slowly, but it does eventually diverge. If you sum them all up, it actually is going to follow a logarithm curve. And if we know that distinction, so that's why I say the harmonic series diverges, but as a sequence, it actually converges. And harmonic series is kind of a special thing in math. I'm sure there's multiple ways to prove that it diverges. But just to be clear on what I'm saying diverges, it's this summation that diverges. Like this sum is never going to approach one particular number. If you make this exponent even like 1.1, or if you increase the exponent of n by any amount at all, it'll actually converge. Like 1 over n is the borderline where things converge or diverge. Sounds good, Zane. Sequence? I mean, for the sequence, you just take 1 over n as n goes to infinity. Like, I can write out... It's kind of a one-step limit. So yeah, I remember looking at proof of why the harmonic series diverges a while ago. I don't know the exact way that it works. If you're interested, I can try and figure it out again. But if you want to look at the sequence for Critical's question, 1 over n, we'll take the limit as n goes to infinity of 1 over n. Which 1 over a very big number is 0, we'd say, or it approaches 0. It isn't 0 itself, but it will approach 0 as you divide by a bigger and bigger number. The series n equals 1 to infinity of 1 over n diverges. And you can do, you would look at the actual terms of the series and you divide them based on powers of 2 is my recollection. And you can figure out a series that you can compare this with. But for critical theory purposes, you don't really need to know how to prove it. I don't imagine. Find a value x such that ln of x is that value. Oh, true, OB. So yeah, critical, so it's 0. For the sequence, yes. We can look at 27, yeah. Maybe bring up 27. And Zane, you can post your question in in the math homework help forum towards the bottom of the channel list or in math discussion. And if you can't find it, let me know and I'll ping you where you can post it. You want to do 27 now? Critical? Absolutely convergent, conditionally convergent, or divergent. Okay. So right, we can definitely do alternating series test here. That won't answer the entire question for us. But alternating series test definitely can be used. You know, make sure to mix up my colors more so the ink drains evenly. We have n equals 1 to infinity, minus 1 to the n over n squared plus 1, right? Right. So there's kind of two approaches we could do for this problem. I'll start by showing you the more natural approach, which is starting with looking at the alternating series, but we do have to look at conditional convergence. So we are going to have to examine the absolute value of this series. So let's start by just looking at the series that we were given and if it converges or diverges. So I would say this is decreasing. Or, you know, 1 over n squared plus 1 is decreasing. And the limit as n goes to infinity of 1 over n squared plus 1, we're just dividing by a very large number again, which is, so we get 0. So already by the alternating series test, we know this thing converges. The alternating series. So at least, at minimum, we have conditional convergence now. Thanks for explaining my background, as I've always done math for fun, and you like solving any sort of math problem. Oh, awesome, last chance. Welcome in. I tend to emphasize homework help more, but yeah, I dual stream to Twitch and YouTube, so if you hear me talking to people who aren't there in the YouTube chat, that's why. If you are familiar with twitch.tv at all, there's a whole little community of people who do math. It's really like a neat place. But of course, if you prefer YouTube, that's fine too. I just don't know as many people on YouTube who do this. Okay, so the next step is we have to figure out if it's absolutely convergent or just conditionally convergent. So let's think about the absolute value of the series. Now I'm actually writing it out here. When I was taking a calculus class, I would just jump straight to chopping off the minus 1 to the n. Like I wouldn't bother writing a list if I'm doing it here just to show you what's actually happening. N squared plus 1 is always positive anyway, so who cares? Negative 1 to the n, if you always make it positive, it's just 1. So I normally just jump straight to this step here. Now to evaluate this series for convergence or divergence. And does this claim work? It's greater than n squared. So if you flip each side, okay, good. I just want to make sure there wasn't some weird thing with plus 1 versus minus 1. Okay, so we can make this comparison here, and this is a p-series that converges. So by a comparison test, we know that this thing converges as well. So converges by comparison test. So that means the final conclusion of the problem is n equals 1 to infinity minus 1 to the n over n squared plus 1 is absolutely convergent. Now, there is a shortcut in this problem, which is we could have started by looking at this, or, like this. And if the absolute value converges, the alternating version also converges. So we didn't have to do the alternating series test at all here if we jumped straight to the chase here, because proving this also proves that. I showed the alternating series test first because it's a bit more of a procedural way to go about these problems. But this particular problem hasn't, or it's like whenever your instructions are like this, you can always try doing the absolute value of the series first and hope that it's absolutely convergent like we have here and save yourself some work. And hey, Anders. Let me know if you have any questions on that. Otherwise, I need to look at Zane's problem. Is it a separate question critical? Because I'm going to need to put you on hold for a minute until we can at least take a look at what the other question is here. Okay, thank you. Gonna post a new question? Sounds good. Okay, let me pull up my Discord. Actually, wait. Let me not pull my Discord. Let me pull up just the images. Questions 93 and 58. Oh, so you posted 44 here. Do you need help with 44 as well, or just 58 and 93? Just 93? Okay. Gosh, we got some geometry here. Let's start with 58 then. What is this shape? So ABCG, ABCG, and DEFG are sectors with center G. So I assume it's the same circle. Maybe we chopped this top bit off and brought it up a bit. So we're taking a break from tough A-level questions. I don't know, honestly, I'd rather do calculus than geometry a lot of the times. But of course, if you need help, I want to help you out. But geometry can get really tricky really quick. So we have AG is 10, AF equals CD equals 5, right? GFA, CDG are 90-degree angles. Calculate the length of arc DEF. Do we not need the radius of this fembox? Oh, you're saying the angle. Okay, so... Okay, yeah, we can do this. We have to do some right triangle stuff. Okay, I'm gonna need to redraw this, I think. Thankfully, this geometry, I know what to do. There's some people who post geometry questions that are absolutely bonkers, but this one isn't it looks scary, but we were able to distill it down to a couple of easier problems, and then just combine our answers. Let's see if we get an answer that matches what Fenbach said. Let me redraw this. FG, okay, good. Zane, yeah, that's the exact thing that I was going to work on first, using the Pythagorean theorem there. So that's perfect that you already have that. Okay, this is it's a funky shape. Already, no, I'm okay so far. Actually, let me label the points while I'm at it too. A, B, C, D. E, F, G. Right angle, 10, 5, and that's 5. I think we can safely assume that CG is 10 as well, because it's a radius like AG is. They don't actually tell us that, which kind of scares me, but I hope it's a safe bet. They should be the same length. Okay, so we'll do my annotations in 10. Actually, in green. So they're asking about the arc length DEF here. And we get arc, and if we want to calculate this, we need to know what the angle is, like around here. So the strategy that I want to use here is we know the angles in this entire circle must be 360. We know that top one is 80. So if we can find this angle here and this angle here, we can subtract out those angles and figure out what the rest of this thing must be. That's kind of like my general strategy for attacking this problem. And you've already found with Pythagoras' theorem, it shouldn't be 11. I think you applied the Pythagorean theorem wrong. It's the right idea, but if you want to find FG, it shouldn't be 11 because it shouldn't. The hypotenuse is always the longest side. Thanks for the follow, last chance. So when we set up this Pythagorean theorem, I'll even draw this off the side here. It'll be rotated as well. GA is 10, FA is 5. That's a right angle. So looking at like distilled down might help you see where the potential issue is. The Pythagorean theorem is hypotenuse squared equals leg squared plus leg squared. So I'm going to set up the equation 10 squared equals 5 squared plus FG squared and solve this for FG. So 10 squared is 100. 5 squared is 25. Subtract the 25 to the other side. You get 75 equals FG squared. Now we take the square root of each side. And because this is a geometry class, I'm not going to... I mean, square root each side, you're technically supposed to put like a plus and minus, but this is geometry and we don't care about negative distances here, so. Square root of 75. And this can be simplified a bit. 8.66, okay. That seems, is that? I think that's reasonable, yeah. I'm going to keep it as square root, but I think we are allowed to round to decimals, but you can simplify this a little bit. If you notice that 75 is 25 times 3. If you haven't learned how to do this yet, then maybe ignore me and just use the decimal that you got. 25 is a perfect square. It's 5 squared. And you're allowed to break up square roots if you have multiplication. So the square root of 5 squared is just 5. So we can say this thing is also 5 root 3. So I'm going to use 5 root 3 here, unless you're really not supposed to do this, but you can also use a decimal, which I think comes out to be the same thing as you got. So I'm going to say this is 5 root 3. Now, I really think we should be able to say that CG is also 10, and that GD is the same 5 root 3. I hope. Like, it will... I guess we can justify by saying AG is a radius as well as a CG. It's weird to me that it wasn't given to us when other things were. What's up, Jed? You don't? Okay. We're sure that ABCDF are still in the same circle? I'm assuming that, and that ABC is translated up a bit. I don't know if we technically know that, though. Okay, so if you haven't done that, I guess I shouldn't confuse you. I shouldn't use the weird square root stuff. 8.66 I agree with. So we can do 8.66 or 8.7 since they say one decimal. All right, so sorry if I was confusing you there. But just plug that into a calculator like you already did and say, I'm going to do one decimal and say 8.7. Welcome in, last chance. 8.7 equals 10. Thinking ABC are points circle of the radius 10. DF are points on a smaller circle. Oh, I guess you're right. It's not the same circle. You can only do this question. Oh, okay, Zane. Yeah, I'll try and move a bit quicker then, so you can get to sleep. Read your earlier comment about FG. You're right. So I think it's not the same circle then. Yeah, actually, they can't be the same circle. You're right. It's okay. It's a little baby according to your mom. Okay, let me speed up then. So hopefully you know. Ooh, I hope. Do you know trigonometry? So if you do you know like sine, cosine, and tangent? So Maxim is defining these two angles here, and there's two different ways to do it. AGF 5, 10, 8.7. So I want to find the angle G up here, so this one right here. So I'm going to show, I guess, two different ways to do it, because I'm not sure which one you've seen before, or maybe both, but if I want this angle here, we'll just call it X, why not? We would say, there's a lot of different strategies here. We could say sine of X is equal to opposite over hypotenuse, 5 over 10. And you can solve that for X by doing the inverse sine of each side, which I hate this notation, but I think it'll be more recognizable. You can say X is equal to inverse sine 5 over 10, and that's something you can plug into your calculator. If you haven't seen this before, don't worry about it because there's another way. I haven't seen you. Which is a bit misleading. It'll be fine, Chet. But you're right. I'm not gonna redraw it, but yeah. So that's something you can plug into your calculator, but you if you haven't seen sine, cosine, and tangent before, you can notice that the proportions of this follow a 30, 60, 90 triangle, because you have a right triangle, one of the legs is half of the hypotenuse, 5 is half of 10, and the other leg is root 3 times that, which is harder to spot, but this fits the proportions of a 30, 60, 90 triangle. So if you know those, the 30-degree angle goes with this across from the smaller side. So 10, 5, 8.7. So this angle up here is 30, and that angle down there is 60. So two different ways to do the same thing. I like arcsine much better last chance, yeah. I'm just doing it that way because that's usually how the notation is introduced as I've seen it. So based off of this, the angles... Okay, sorry about that. My mic didn't charge overnight, apparently. Don does mute math, yeah. Thanks. I don't know when exactly I cut off. Okay, it sounds like I cut off around the time I was explaining that 30-degree angle. Okay, so Zane, I'm so sorry about that, and hello to GADD over on YouTube. Okay, so Zane, are you on board with that angle being 30 degrees? I was trying to explain how you could solve it either using trig, which you may not have learned yet, sine, cosine, and tangent, or you could recognize that it's a 30, 60, 90 triangle. You know it's 30? Okay, perfect. In that case, then we're not too far off. The only other thing that I did then was find the angle for, I don't know if it's better to call it DEF or DGF. I'm not a fan of like notation, but either way, we do 360 minus the 3 other angles around it to get, it's gonna be hard to explain, to get the angle I'm about to point to now. Sorry, I'm stuck with this mic and it's stationary, so it's gonna be the best that I can do. And so now, if we know that angle is 220 degrees, we have a formula for the length of a sector of a circle, which is what the question is. And I'm just gonna type it out, I guess. So the way that I remember it is you take your general formula for the radius, or for the circumference of a circle, which is 2 times pi times the radius, which we solved for as 8.7. And then to make it a sector length, oh god. How do you do this without radians? Do we have to do in radians? Do we have to convert 220 degrees to radians? Never mind, let me Google this. Probably simpler for I remember it a complicated way. I want to find the way that you probably learned though. Theta over 360 times pi r squared. Okay, let's take that formula then. I don't know how well it comes. Oh my, go away. Okay, your angle over 360 degrees times pi times the radius squared. I'm just gonna plug that in. So 220 degrees divided by 360 degrees times pi times the radius we said is 8.7 squared. So the answer that I get is 145.3. That's an area? Oh my god, you're right, Fembox. I'm sorry, I'm getting the... Oh my gosh. Arc length. I'm sorry. I got my... My terms mixed up. God, that's a stupid mistake to make, isn't it? Okay, so I'm sorry, Zane. I accidentally found the area of that. We want the length of the arc, which is different from the area of the sector. Oh my gosh. They're giving a few different versions of the formula here. We can do... This is the way that I would remember it the most. So I would do the angle divided by 360 times 2 pi r. So the angle divided by 360 times 2 times pi times r. 33.4. That's the arc length, not the area. Wouldn't it just be the circumference times theta over 360? Yeah, last chance. I just apparently can't remember that. Or I was getting mixed up with, like, is this pi in radians? Do we have to worry about that? But you got it? Awesome. Yeah, I made this 8.7 when it shouldn't be. Or it was 8.66 or something, but it was actually like 5/3. You can get the exact value if you prefer. But it's not like we matched Zane, so I'm glad that we got a matching answer there. No worries, Zane. Sorry for the slight hiccup there, but with the mic and all. So I know you have to go, Zane. If you want, I can get back to you in text on your other problem for 93, and you can look at it whenever you have time on the Discord. Oh, glad to hear that, Zane. Okay, I'm sure I haven't missed anyone else. Right, I do these math streams on Tuesday, Thursday, and Saturday. I started a little late today. I normally start 3 hours ago, whatever that is in your time zone. Hey, SPQ.
Oh, last chance. Sorry, in this chat and a few other the math streamers chats, we do these things called saves, which is if you help out with a problem, or if you just kind of do anything that's even remotely helpful, they might give you a save. It's kind of like a for fun tracker for if you help people out. So if someone helps out with a problem, then I'd like to give them a save. And actually, if you don't know of other math streamers, I should do a shout out to the ones I can recommend the highest. Tuesday, yeah, sure. So in that case, I won't work on 93 until I see you pop up in chat. Then the next time that we're doing math. All right, so I think there's no one else in chat who's waiting, so we can go back to critical. Okay. Oh, you're already here anyway. Zane, 3 hours ago, whatever that is in your time zone, is my normal start time. You're in England? Okay. Hey, random dude. How's it going? And if you do know Twitch.tv, that website, there's other match streamers out there too who stream at a variety of times. Subbed? Awesome. Well, thanks so much, Shane. Hope you have a good night too. Okay. So how am I gonna? I'm about to go up to the whiteboard, but that's not a good idea right now, is it? I guess we're gonna pull a Dan and use Paint. My mic has a chance to charge for a bit longer. Conflicted, but physically you're okay. Oh, okay. Like whatever that conflict is, be able to figure out a way to deal with it. Okay. What's happening here? One over ln or alternating 1 over -1. This might be an integral test. Funny enough. Yeah, okay, so... Oh, yeah, do you have something to say before I get into it? That was the whole point of the question? Okay. Yeah, critical. Every time I tell you, like, that I don't use something, I feel like you're getting tested, like, a lot more thoroughly on these than I got tested in my calculus classes. It's like I almost never do the integral test, I feel like. Do the integral test and submit the homework. Okay. Well, let me just say, I would do the integral test on the absolute value of the series, not on the alternating. Like this right here, I would do integral test. The alternating version, I do alternating series test. Okay, yeah, good. We're on the same page with that. Random dude says, nothing big, just had some hidden grandma Laura just suddenly dropped you. Now you're wondering who the hell your grandmother was in her past. Oh. That's fair. I've had a similar, like, revelation, I guess, not of something they did negatively, but rather something that happened to them that I was completely unaware of. So I don't know exactly what it's like to be in your shoes, but I know it's kind of a weird thing to deal with mentally. She had to do like everything. Yeah. So when the instructions are like this critical, I would say you can save yourself some work if you check for absolute convergence first. Because if it's absolutely convergent, then you're just done. So this time I'll do that first. Whereas the last time I started with the alternating series, I'm going to start with the absolute value. So when we examine this series here, I would apply, this is always positive and it's always decreasing. So I would apply our integral series test. And integrating this is no fun, is it? Oh, what the heck? How do we integrate this? I guess we integrate by parts. Because I can't think of a comparison for this. I mean, I might be missing. I wouldn't be the first time I missed something with an integral. Let me plug it into Wolfram. Just see if it comes out of something stupidly simple and I missed an easy U sub. Why is it just ln? I think I'm missing an easy U sub. Can we compare with 1 over n SPQ? That'd be nice. I thought it, for some reason in my head, I thought it didn't work. Like the inequalities go the wrong way. Oh, 1 over log x, that does not have a clean integral. I'm never mind this. I'm not sure this is, it shouldn't. I'll show what I'm getting on Wolfram. What? There we go. If I integrate this, I get Li of x, which is the logarithmic integral, which is something, I think it's just the integral of the logarithm, which isn't that helpful. I think it's some weird exotic function. Yeah, it's this weird thing. So I take that back. I would not do the integral test. I think SPQ, yeah, SPQ again caught what I missed, which I'm very grateful for. I thought of this comparison, but I messed up the inequalities in my head. So yeah, looks like we can do a direct comparison test, because how I would think about this is we want to compare the functions ln, n, and n, and I want to put an inequality sign here. And we can do that by thinking about the graphs of each. So ln of n looks like that. I'm treating them as continuous functions here. I should really say x instead. It's fine. ln of n, a logarithmic curve looks like that. A line looks like this. It's possible that I drew the curve a little bit like incorrectly here. Actually, it's more than possible. So like maybe the point is, no matter where I draw this curve, they might intersect at some point, but the line is always going to take over for a big enough x, or n in this case. So we'd say generally after a certain point, n is greater than or equal to ln of n. And now if we flip this inequality, we get 1 over ln of n is greater than or equal to 1 over n. And that's what we want. That's what I messed up in my head. So we can make the claim now that n equals 2, which we should, I mean, I guess technically we should check it for the starting index. It doesn't actually make a difference though. After 2, we're definitely safe though. Just like around 1 that it might be weird. So we can make this claim here, that whenever the sum from n equals to infinity of 1 over ln n is greater than or equal to the sum from n equals to infinity of 1 over n, and 1 over n, of course, is the harmonic series. So it diverges by the comparison test. The harmonic series, it is a p series. If you want to say that this is a p series with p less than or equal to 1, that's valid too. It's really we've talked about before. The harmonic series is a special case of the piece of a p series when p equals 1. So you're technically correct in saying either one of those. No worries. If you have more questions, then keep them coming. I'm gonna take a second to erase the whiteboard though. Oh, and you're thinking that harmonic series is a kind of geometric series? Oh my gosh, you're right. I didn't actually answer the question, did I? All we've shown so far is that it cannot be absolutely convergent. We've eliminated this possibility. We need to test the alternating version now to see if it's conditionally convergent or divergent. So now we do want to consider the alternating rate. So for our alternating series test, I would make the claim that 1 over ln n is decreasing. And the limit as n goes to infinity of 1 over ln of n. Ln of n, it still goes to infinity very slowly, but it does go to infinity. So we have 1 over infinity, which means we get 0. So by the alternating series test, it converges. That's all the final answer. The final answer is that this thing is conditionally convergent because we got convergent for the alternating and divergent for the original. So I would say that our actual answer is conditionally convergent. Yeah. Whenever you have a limit in general, with ln, it's a good thing to know. Oops, that's not. If you have the limit as x goes to infinity of ln of x, this is just infinity. And so, of course, in this situation, we had 1 over that, so we went to 0 instead. But ln is kind of a weird function because it looks like it levels off over here, but it doesn't actually. There's no horizontal asymptote that you can draw. It will eventually like hit every possible y value up here. So that's why we say it still goes to infinity. Yep. Are your questions from yesterday, did they get answered? No, you can't use the integral test, or unless I'm missing something, I don't think it's possible to integrate this easily. Or I don't, in a normal calculus class, you would say this isn't possible to integrate, I think. You need some crazy stuff as far as I can tell. Yeah, exactly what SBQ is saying. So yeah, I was thinking about the U sub that I think you ended up using. If you take, well, I guess you do U equals ln x. Du is 1 over x dx. So when you plug it in over here, you would have 1 over u, yeah, as you say, x du. And this x is the issue. You could technically rearrange this to say e to the u equals x and plug this in. That could maybe be possible to integrate by parts, but I kind of doubt it unless you're willing to use some special functions. No, integration by parts probably doesn't even work. You don't have to do that if you don't want. It's just we can't integrate it. No, x is not a constant. Okay, so that's where the issue was. X is still a variable. The integral is in terms of u, but x is dependent on u. I guess I should say just because there's a letter there doesn't mean it can't be taken out of the integral. But in this case, with doing a u sub, that's a big no-no. If it's just a constant, like if you how about x to the, what is that? I don't know what that means, critical, I'm gonna be honest. There's a lot of ones in there. Integrating x to the 1 plus 1 over 1 plus 1? Is that what you're saying? This is a very odd... No? Okay. Wait, like that? Are you saying if we had different numbers here or something, or? Yeah, okay. I'm not sure what the question was, but I'm gonna, if you want to move on, I'm down with that. You're saying 33? Didn't we do 33? That's the Harmonic series one. Like that one, I thought we just did that a minute ago. Oh, okay, okay. Where is it then? Let me see. Oh, yeah, that's kind of a neat, it's probably more complicated than critical would have to do SPQ, but that's a neat way to try to force that way to work. And tell you, there is the integral comparison test too, if you want to show the integral diverges. So maybe that would open up some avenues for you. I think that's what you were saying. To do something like that with integration by parts to get a different looking thing. That's a little bit too small, isn't it? I think we did this one too. Maybe 2 days ago? This period diverges because e to the u over u does. Oh, okay. I think you get something like that for integration by parts. Either way, e to the u over any polynomial is going to diverge, right? I imagine, at least. That's the reason why I use integral test on the other one. I wouldn't do integral tests here. The integral is going to be really messy. I mean, on this exact thing, I wouldn't do integral test. You could translate this to something else and then do integral test on that. Do you remember how we dealt with the cosine up here? Oops. -1 to the n. Good. So yeah, if we want to look at absolute convergence, I believe the integral test is allowed on this. I think you could actually do the integral test for the harmonic series if you wanted. I can't think of a reason why not. It's my instinct to just compare this with the harmonic series, but I believe you could validly also do the integral test here. And this integral isn't too bad. You could take u equal 3x plus 2. And I should say the conditions are met. -1 to the n? Oh wait, you said that before though. Okay, never mind. I should say the conditions are met because this series is always positive and always decreasing. du is 3dx. So what we get, I'm going to chop off the bounds for now because that's how I like to do these. Dx is 1/3 du. So the 1/3 comes out front. We get ln of the absolute value of u. Unsub and bring the bounds back. It's a lot of vertical bars happening here. And here we would get the limit as x goes to infinity of 1/3 ln. I should put big brackets around this. Minus, and then our lower bound. This is just a finite number. But over here, we end up with ln of infinity, and as we talked about before, ln of infinity is infinity, so I'd say this thing diverges. Or the integral diverges, so this series over here diverges. Now, it's not the answer to this question was absolute conditional. Oh, I don't know what the instructions were. The absolute value of the series diverges, I would say. So you think that was the other one? Okay, well, I got mixed up then. Or actually, I guess you said it was the integral test. Right, I agree, it conditionally converges. Because the absolute value definitely does not converge that we just showed. But if you did use the alternating series test on this one, it's going to go to 0. Was with sine? I feel like we did this one too, but it doesn't matter. I don't think we did the integral test with any of these, so. Right, yeah. There's the other one with sine that we definitely did this one too with cosine, but yeah, the other one with sine that was ambiguously not worded, but set up. So you're like, could you use the integral test on the harmonic series? Oh, wow, that's an example that Paul's Notes gives. So another way of proving that the harmonic series diverges with the integral test, apparently, which for some reason I feel like isn't right, but I guess it's fine. Interesting. Prepare. Oh, your finals next week. Okay. Geez, well, good luck. Are you not doing like ratio tests or retests at all then? Or are you just still like working on this stuff before you do those? You did? Oh, okay. It's not really included? Oh, okay, that makes sense. Do you do Taylor series also then? I'm just kind of like curious. Or maybe a McLaurin series or just any type of like power series? Gonna learn. Oh, okay. Fair enough. It's weird it's weird that's not on the final, but I think that's gonna be to your benefit because those are kind of like big topics. So Taylor series, power series. No math stream tomorrow for me. On a Sunday, is Ian Stuckey still out? Ian Stuckey is normally streaming on Sundays, but I feel like they have a weird schedule. Oh shoot, I don't think. Wait, is today? Okay, yeah. Ian Stuckey won't be streaming on tomorrow then. Neither will Penn Center. Dan won't, Zach won't, Gold won't. I don't stream Mondays either. Those are both my off days. I'm not scheduled to do another math stream until Tuesday. Hey, Phobos. How's it going? For people who are streaming on Dan and Actual Education or Gold should be streaming on Monday. Oh, or there might be a stream from Obi. It's cold? Really? For me, it's hot. Very sure with this problem by yourself and asking a question on Tuesday. All right. If you want, though, it sounds like Obi may throw a stream in. You have a more urgent question. You have streaming until Wednesday. Dang. This time of year. Fair enough, Phobos. So also Monday who I'm forgetting, Ian Stuckey normally would. Penn Center normally would. No, Penn Center normally would not, anyway. So yeah, I can't think of anyone else. So yeah, there may be a stream from Obi, but otherwise on Monday there'll be Dan and Gold. Cold in Buffalo? Interesting. It's been this week's been heating up. It's like 80 something degrees today, Fahrenheit. Hey underscore. That's a cute little like greeting. Had a birthday party, bought a cute cup for it and everything, but it was cold and rainy. Oh, cute top. Why did I write I combined cute and top into cup. It's like, oh, I don't know why you bring a cup to a party, but okay. It was cold and rainy. That sucks, Phobos. I'm sure you'll have a chance again eventually. Is my mic charged? Man, I don't know how much it's charged. I don't know if I want to risk using my lapel mic. Okay, so it seems like we don't have too many more questions from chat. We could go back to doing the physics stuff. So I still want to write that little update for people. And then once we get that done, we can do a little bit of algebra maybe. Unless someone asks the question, of course. Okay. So what I'm doing right now, I started off the stream with looking through it a bit. Actually, let me explain that. For this physics reading group, sorry, I need to close out like all these tabs. For the physics reading group that I want to do, I started the stream by looking through chapter 1 and trying to get a feel for how difficult it's going to be. It's a little long and it's got a lot of stuff. The question posted in Zach's chat. Oh yeah, with the quartic, it's like x minus 5, x minus something equals 360. Zach's way of doing is a lot more clever than mine. No worries, critical. I was gonna do it the hard way of like I had in my head a picture of a generic quartic and I drew a line at y equals 360 and I was like, we probably only have 2 solutions, but we don't really know that. We could have 4 or 3. I didn't see. I think Cold Gold said a neat way to do it that I didn't catch though. I was busy like doing other things at the same time. So I forget what the like nice trick was. Yo, hard locked. How's it going? There's some kind of like symmetry that you can take advantage of, right? Hey, Bradley. Since like, actually, I haven't even started doing physics yet. So like maybe since like today or something. But I am starting this physics like reading group to do electromagnetism with multivariable calculus because it's just kind of I'm interested in trying to learn it. And since there isn't a math question from chat right now, I've been looking through this book a bit and trying to get a grasp of how difficult it's going to be, and maybe say like, or I'm trying to come up with a, you know, what pace we want to try and take this at. So I was kind of looking through chapter 1 and saying like, it's kind of a lot here. I might want to give like 2 weeks for us to read it, and then we'll meet and discuss it and try some problems. Even problems that use symmetry is such a nice approach to be able to use. Yeah, it is. If it applies at least. So you're not looking at Jackson? No. We were debating between Purcell and Morin and Griffiths, but we're leaning towards Purcell and Morin. And so I was writing a little announcement in my Discord, because why not just do this on stream? That's a nice objection. I think both Purcell and Morin book is please you get PF, yep. Versus standard. I've heard that too, but the Purcell one sounded interesting because I asked Physics and Depression for recommendations, and he said that this Purcell one gets into like relativity, and I just thought that was kind of like cool if I'm able to understand it. Like it introduces it like very early on. Something like that at least. So wait, unless anyone has any objections, we'll go with this book, and then tentatively plan to meet on, what would that Saturday in 2 weeks be? The 25th of May. I should get the timestamp. 1 second. May 25th at 1 p.m. my time. Special relativity was born from Einstein trying to make physics consistent with electrodynamics. That, yeah, my only experience with like having studied those is reading Stephen Hawking's book, A Brief History of Time. So like I know conceptually like a tiny bit about it, but even then I kind of forgot that. The date, say I need time or similar or whatever, to discuss the content and try some of the problems. I guess that's like the gist of what I want to say with this post. Of course, things as possible. So if we need to adjust the book, scheduling, timeline, whatever, please share your thoughts. Thanks. That makes it sound too much like an email I write at the office if I put that thanks on the end. I'll probably do some of this reading on stream if I have some time to fill. Time that needs filling. But I'll attempt problems too seriously until we meet. Well, it's like that. Okay. Cool. And make sure this timestamp worked. Okay, good. So, I mean, technically we can even start reading through the book too. But we could also wrap up chapter 3 of the algebra stuff, because that's going to have to go on pause until Penn Center gets back. We'll do some algebra, I guess. You know what? I don't have my whiteboard, do I? Well, I mean, I do have the whiteboard, but it'll be difficult to use it. I'll use paint still. I was gonna go through Don Shout's math. What happened is I usually have a little like lapel mic that I use, but for whatever reason it didn't charge last night, so it died, and I didn't realize it for like 5 minutes. So I'm just using this like mic that's stuck in place, or travel with me. Oops, sorry for the bumping. Okay. So did we officially do? I remember we ended on 76. I want to say I don't know if I actually did it or if we just thought about it. Oh, I tried it my way. I realized my idea didn't work as it was, and both you, Phobos, and SPQ put in ways that actually worked. That's right. Something Kaylee table. Yeah, that was basically my recollection of what you said. SPQ, I remember, did SPQ consider the set GH and showed some kind of contradiction there. Reminds you of Sudoku. Oh yeah, so I still haven't like completely come to terms with that argument, I guess. For any given x, there's n x's for an n by n Cayley table. And if we remove the row and column that go with x, why does that matter? Like, what does that break? You still have x in the table. Oh! Duh. Okay. Thank you. That's the argument that I think I wanted to make. It just was, it's hard to do it symbolically, I guess, or like algebraically, or I don't know, that's the right word, but like, yeah. I wanted to take G and get somewhere in H, or take somewhere in H and get to G, but it's hard to do that if you don't know what the elements actually are. Wait. Maybe my argument does work. I thought my argument didn't work, but I might have just cracked the case. Let me go to Paint. I guess I should really open up Overleaf for this, right? But it's for nerds. Okay. Oh, that was the problem in an earlier section? Let me actually look at that. Chapter 2, 31, page 56. All the PDF pages aren't going to match. 31. Oh, that problem, yeah. It has to be a consequence of this. That's a fancy dagger symbol, by the way. Usually it looks like a little cross to me. Anyway, I want to see if I can make my argument work. Because it's an argument that makes sense to me. So, oops. Here, okay. You can use text, not red text. 78? No, not yet, Enders. Planning to at some point, if not today. Let G, the order of G equal N greater than 2. Let H be less than or equal to G, and the order of H equal to N minus 1. Then there is a singular element in G, or there's a singular, oh my god, a single element in G minus H. Let it be G. It was, oh wait, no. What? Oh no. I thought I dealt with the issue. Oh no, I just ran into the same exact issue that I... God damn it. G being self-inverse was the issue with my argument, and I didn't actually deal with that. You hate singed elements? Same. I prefer my elements rare. But if G is I mean, it must be. Really? It's monkey in French? Dude, I kind of wish that we would consider groups of monkeys. I don't know what the operation would be. But I feel like math would be a lot funnier if we did. You know what? Maybe there's a completely different argument than the one that I was thinking here, which is Are we guaranteed in a group composition? All right, that's a really good one, Vlad. We um gotta make more monkeys somehow. Um I'm interpreting it as like a sex joke if you're composing two monkeys. Because if you're composing two functions, it's like put it in one function inside another function. That's where my brain went, at least. Monkey needed a typewriter to do composition. Dirty people. I appreciate a good dirty joke. I also appreciate really immature dirty jokes too. It doesn't have to be good. Okay, so I realized the argument that I wanted to make when I first opened up this paint doesn't work still. But can we say that since G is closed, let A B equal G, where A is not equal to G and B is not equal to G. Can we do this? So, Anders, that's where I want to go with it at first, but what if G is self-inverse? That was the issue for me. What is the order of that subgroup? I mean, be ordered at least 2. If G squared equals E, we can reuse a result from before? Really? G is not a union of 2 proper subgroups. Oh. I forgot about that SPQ. Prove that a cannot have a subgroup. Well, right. Well, does prove that. Does that mean that it can't have a subgroup of order n-1 though? What if does that cause a contradiction for that n? Like, can we make it clear that the contradiction is with that n-1 subgroup, I guess? This immediate. If G is order 2, then G equals H union G. I guess it is. I'm maybe overcomplicating it. Yeah, I guess I was worrying that, like, what if the subgroup that's wrong is the other, like in the subgroup generated by G or something. But I guess they're both. I think that's overthinking it. So in that problem, did G have to be finite? Let's just check that. I think it was in the previous chapter. Was that Putnam problem? Was it in chapter 3? Oh, it must have been in chapter 3 because it involves subgroups. Just to make sure there. No group is the union of two proper sub. Okay, fair. I guess that does kind of do it for us. Anders, if your argument, if your argument works though, I'd be interested to hear it too, because that's the one that comes more naturally to me, I think. But yeah, what SPQ is saying is a good one. Because like the subgroup generated by G is at least order 2. Oh wait. Oh, actually that isn't the entire argument though. You're saying to deal with the G squared equals E case, right? So we can at least like go and fill in the rest of the blanks there. Which in this case, the subgroup generated by G is equal to the original group. If it is though, that means that H isn't closed, right? G is not equal to E, since then H cannot be a subgroup. If G squared equals E, then G equals H. I'm just gonna write the letter U. H union G. But no group can be the union of two proper subgroups. If the order of G is greater than 2, now we can make the argument that H won't be proper because then G squared must be an H, and cannot be E, also must be an H. Which is a contradiction, which contradicts. Can you say the closure of H, or is closure a bad word to use here? Which contradicts H being closed, I guess. It's like the closure of a set is something specific, right? So maybe I shouldn't say that. The cosets are still the simplest though. Yeah, it's just not something that I've learned yet, I guess. But yeah, this argument right here is the one that I wanted to make. I just forgot about the g squared equals e case, and I didn't know how to deal with that, so I threw out the entire argument. That's a nice catch there to salvage mine. Okay. So 77. Let A belong to a group in the order of A equal M. Penn Center. How's Costa Rica? How did I conclude? Oh, I can show it again. Quick hello before dinner? No worries. Thanks for saying hi. Yeah, well, I would say, like, you know, you should get off Twitch and go enjoy being in Costa Rica. I do appreciate you being here, though. Yeah, I'm good. We've had some fun questions today, and just working on some the last few questions in chapter 3 for the algebra textbook. A particularly rich coast that way. I've heard that too. Went for a long drive to some viewpoints just in some downtime. Oh, okay, nice. I bet there's some amazing views there. So yeah, I guess this was my conclusion underscore. Like, I guess I should technically write in another sentence of, like, therefore. And -1 cannot exist. Oh, I guess there's like duplication there. Is that a contradiction? I mean, this is a contradiction. I mean, maybe I could have phrased it better, but E or G. Because if G is order greater than 2, then G is just some other distinct element. But every other element is over in H, which means that H, there's, you know, a pair of H's such that we get to G, which isn't in H. Yeah, and so G is that thing out of H. I guess it's a little bit backwards, maybe. Let me actually make it bigger. I feel it's too small for stream. But if the order of G is greater than 2, that means G squared is some other distinct element in G. I mean, okay, let's maybe rephrase this. In integer addition mod 4, 1 is out of 0, 2? I don't know what that means, I guess. Aren't you leaving off 2 elements there? Because you left off 1 and 3. but its square too is in 0, 2. Yeah. Oh, I guess I see what you're saying then. Um, and you're up arrowing to SBQ. The order of G is greater than 2, then G cubed is not equal to G. That's constant G squared not being equal to E. Okay, okay. Then I haven't read the rest of your argument yet. Let me see if I can work through it. G cubed isn't equal to G. I mean, right away, that makes more sense to me. G cubed isn't equal to G. Okay, fine. I'm gonna look at the rest of your argument. Oh, I see. Okay. In G cubed in H is in H. Well, I guess we make the same argument for G negative 2. Okay, can you get the same rearrangement starting from the statement for G to the negative 2? I think it's writing that for my benefit, because the part that I'm stuck on right now. So we should technically do the same argument for G to the negative 2, but there isn't this clean manipulation here that I can find. Implies that G squared is an H. And oh, okay, I get it. But G cubed times G to the negative 2 equals G, which is not in H, so H is not closed. Okay, that's clever. I see where I went wrong even more now. Thanks for pointing that out, underscore. Enigma had the idea a while ago to try to make a an Enigma bot able to render LaTeX and like make it as an emote in Twitch chat. I don't know how well it would actually work, but it would be kind of neat if it did. I imagine it's pretty complicated to actually do, but I feel like theoretically it's possible. Just would have a lot of like practical issues. But okay. What does 77 look like? The A belong to a group. You're right. Yeah, that's a thing. Every time I want to move on, someone points out a valid error. That will probably address it. Because in this case, we're assuming G squared is E. So E comma G should be a proper subgroup. And it's okay if this is order 2, because we only care that H is order n-1. Yeah, I think this is okay. Yeah. I was like trying to think about it more, but I think that's enough to address it. I didn't actually prove that a self inverse element forms its own subgroup. I mean, it's just the order. It's subgroup generated by that element, though. Yeah. So actually, okay, you know what will be... SPQ underscore even said this before, and I just wrote my own version of it. I think it'd make it like this is more clear. Just use a subgroup generated by G. And that'll end up being E comma G, but this is more obviously a subgroup, I guess. I guess it's still a proper subgroup because we're saying G squared equals E. And we know the order of the initial group is greater than 2. Too bad we can't use Lagrange yet. We're slowly getting there. It'll be a while still, but eventually we'll get there. Okay, so now 77. Let A belong to a group in the order of A. Jump ahead. Lagrange us. Lagrange me. It's in the same chapter as cosets and there's been liberals. That's true. Okay. You know, what chapter even is Lagrange in? Let's just look at that. Let's prove Lagrange as an exercise. Oh wait, does the book not call it Lagrange? I feel like for some reason that might be the book's version of Lagrange, or am I crazy? Where even is... Okay, fine. I'm going to the table of contents. Seeing if the word Lagrange actually appears here, or if it has a different name. Application of cosets to the Rubik's Cube? Oh, that's kind of cool. Oh, Lagrange is here. Oh. This doesn't have links. Okay. Book page 142. That's a bit more than 142. It's a bit less than 142. That's a bit more than 142. There we go. If G is a finite group and H is a subgroup of G, then the... Oh, it's this one. That's right. The distinct left and right cosets of H. Oh, God. I kind of hate this, but I assume left means order of G and right means order of H. Or no, I don't know. So it's not that. It's just, it's for left and right. Okay. Yeah, no, I was just confused. Like, well, normally I see this parentheses thing. That means whatever's in parentheses over here matches right, but there's nothing in parentheses over here. It's like, oh, so maybe it's the slash, but no, I don't mean that either. Do the coset dance. Slide to the left. Slide to the right. Yeah, I don't know how to prove this yet. So conveniently, there's a proof right there. It's pretty short. But anyway. Be a while still before we get there. Okay. Let A belong to a group in the order of A, B, M. If N is relatively prime to M, wait, yeah, show that A can be written as the nth power of some element in the group. Cool. All right, I am getting rid of this. Before someone points out another mistake in my work. Okay. A belong to a group in the order of A, B, M. If N is relatively prime to M, show that A can be written as the nth power of some element in the group. Huh. We can use the Lagrange. Thank you, SPQ. We don't have a name for this group, do we? It's the nth power of some element of the group. So, what I'm thinking so far is if they're relatively prime, that must mean that, like, the subgroups they generated have some kind of, like, offset, and that offset Like, that's what I mean by offset is like if you get locked into an even power, or not an even power necessarily, but like what am I saying? I'm not sure what I'm saying, to be honest. Hmm. Well, no, 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 no. What am I doing? It's not an infinite group. M is finite. So, yeah, zone is like I never think to use stuff like that for my arguments. I'm trying to do some kind of like I don't know what I'm trying to do. I'm just always trying to use generated subgroups, I guess. So we're saying M and N are relatively prime, so the GCD is 1. Wow. Okay, let's see if we can follow this then. Okay. Yeah, that's not how you spell since. Mn relatively prime. Ms plus nt equals 1. So a to the 1 equals a to the ms plus nt. And split this up. And I'll get the rest of the zone range to comment quite yet. Let's see if I can figure it out from here. Ooh, a to the m to the s times a to the n to the t equals e to the s. Yeah, underscore. That, I appreciate it, but I guess you got beaten to it. I mean, okay, you know, I did kind of cheat and I had already looked at the rest of Zone Ranger's comments, which is why I did the grouping thing right here, but I misremembered it and did the grouping wrong. Oh my god. Freaking paint. So I'm saying to keep the N on the outside. So A equals G to the N, where G equals AT. I was wondering, do we know that a to the t isn't a? Well, I guess then that would be a contradiction. I was wondering, like, I'm trying to figure out why we've assured ourselves that a to the t to the n, or, you know, a to the t in parentheses to the n doesn't break the original prompt in some way. A is the nth power of some element in the group. And the only way that this could possibly be wrong is if a to the t was a, but like I said, that was a contradiction. I'm trying to make sure that, like, or I want to know for myself, like, why we haven't. They didn't say distinct element, but I think the distinct part. Yeah, okay. I guess if I can insert the word distinct here, that would, like, clear it up for me. You're saying one is co-prime with m? That kind of hurts my brain. I guess if one isn't a prime number, or isn't one a factor of m? You're saying n equals 1 is fine? Oh, okay. N is relatively prime. That's a weird thing with the definitions. Did it sub with Twitch co-prime? Maybe it doesn't need to be distinct, like you're saying SPQ. If n is relatively prime to m, I guess if, yeah, you have self-inverse things, you can have, like, that, like, you know, a cubed equals a to the fifth for anything that's self-prime. Or it's self-inverse. I guess I was kind of misunderstanding that I had then. So we would just... I guess so. Okay. Maybe I'm just overthinking, like, things that are potentially wrong with a to the t to the n. I guess let's get through 78. A GB finite group with more than one element. Show that G has an element of prime order. All right, maybe I want to start by thinking about this with like order 2, order 3. See if I can spot something. If we consider 1 as a prime number, this becomes very easy. Induction? I mean, I don't know if induction is really possible in this, but if there's a way to make induction work, that'd be cool. I guess I'm trying to get a grasp of why this is true. If we have a group of order 3, A and B must both be order 3. Right? Is that another Lagrange thing, though? I feel like we've observed that without actually proving that. I'm just going to say it. Yeah, I mean, this is really just like an exploration for me to understand the problem, I guess. The available orders here are 2 and 4. I mean, must something be order 2? Could everything be order 4 or order 1 for the identity? Hmm. The order of G is a prime number times some other number. Well, yeah, sure. If we have like the order of G is 4, that's 2 times 2. How do we use that to our advantage? What does that say about G? Like, what does that say about, I guess G squared? Oh, G squared has order 2. Ah. Okay. That's clever. Yeah, I'll use Zone Rangers like set up there with the order of G greater than 1. I should just use the text tool here, right? That'd be much smarter. Rather than drawing this with my mouse. The order of G is not prime. Then the order of G equals P times K for some prime P, and I feel like it's not too far from my normal handwriting, which is not a compliment to my normal handwriting, but thank you, Phobos. I mean, we can say integer. It's not as exact as it could be, but it's good enough. I think I was saying like natural number or something, but who cares? The order of G to the K is equal to P. That's what we're saying? Yeah. Okay, that's pretty simple. Saves at 0. I think I go to generators too much with proofs, at least with these last few problems. Because that's when I was like drawing out exact cases, that's kind of, I was trying to figure out if I could see some pattern there. I may not do literal induction, but some kind of like a pattern thing there, I guess. But this is like way more simple. Also, Phobos is helping out there. Not forget that. And I guess that's the end of... okay, there. I guess that's the end of chapter 3. I don't particularly want to work ahead to chapter 4 until Penn Center's covered it on his stream. So I'm either... Yeah. I'm either gonna maybe revisit some of the ones that weren't assigned in chapter 3 or even 2. Or we'll do some physics reading. Or both, because we don't have to be limited to just one thing. Dumbit and Foot? Are those actual author names, or what is that? So we're gonna do cyclic groups next. Oh, those are actual names? That sounds like a joke name, to be honest. Okay. And then permutation groups, and then we get into isomorphisms after those two. Send from there until you hear about the reading group. Oh, okay. Someone used that book in grad school. Okay. So I'm not sure exactly what I'm gonna do with this algebra stuff. I guess we can always just go and do some of the ones in the gaps. I mostly selected what Penn Center assigned for chapter 3 here, and we could always look at some of the ones that weren't assigned by Penn. But you will show that for any prime divisor P of the order of G, there exists an element of order P. Oh, okay. So that's the question I was asking myself when I was doing those cases with if the order of G is 4, like I was wondering if we had to have an element of order 2. And I was trying to think some kind of contradiction if we didn't, but I didn't quite get there before Zone just gave the way simpler answer. So yeah, I think I might wrap things up here for the day. He's gone for the first course in algebra that I took and have taught of. Oh, nice. Okay. Let's see if there's any friends who are going. Oh man, no one in my follow list is going. Let's see. If I just generally search math on Twitch, what comes up? Okay. I might not be able to find someone to raid today. If someone has a suggestion, then let me know, but... Someone just saw algebra I call shenanigans. Even with that same book, too. That's cheating. No. Okay, yeah, I can't find someone to raid, unfortunately, so